So let us start properties of definite integration. Okay. In definite integration, so far we have learned the fundamental theorem of integral calculus. Fundamental theorem of integral calculus, two statements are there. Area function, it is a2x fx dx. Then derivative of, this is known as area function. Derivative of area function is fx. Okay, this is theorem 1. If ax equal to this, then a dash x equal to fx. And theorem 2, what you did? Function fx is defined in an interval, closed interval. Say we are taking the interval a to b, both the functions fx and phi x are defined and continuous over there, and we are referring phi x as primitive of fx. Then primitive means derivative of phi x is fx. Then fx dx a to b equal to phi b minus phi a, isn't it? This is fundamental theorem of integral calculus. So far, use of this we have done in many sums. Now, in properties of definite integration, sometimes just by seeing the question, we can state the answer. Okay? And all the properties I am going to state here, those will be based on this theorem too. But those are given in compact form. Just seeing the problem, we can predict the answer. Let us write all the properties with proofs in some cases, which is not so difficult. Okay, I mean which will not take much time. So let me write the property. Properties of definite integration. The value of definite integration is not dependent on the variable used. If we evaluate a to b fx dx, the variable is x. Somebody change the variable to say ft dt. This will have the same value. If you change it in terms of another variable z, it will have the same value.
Sir, but then we have to change the limit.
No,
also.
no one change of limit is required. I am just showing you. For example, if we use the concept of fundamental theorem of integral calculus, I am just asking you what is the value of x squared dx? 1 to 2, t squared dt 1 to 2. Same value. There you write x cube by 3. 1 to 2 value is 8 minus 1, 7 by 3. And here this is also 8 minus 1 by 3, 7 by 3. Do you find any change in the answer? Whatever variable is there, the value of definite integration is not dependent on the variable chosen. The second property is, if we interchange two limits, a to b fx dx, it will be minus b to a fx dx. A to b fx dx is equal to minus b to a fx dx. This is very easy to prove. I am not giving you the proof here. You can realize in fact with examples also. Number 3 proof I will give you. What is number 3? It is very important, probably most important property here. 0 to a fx dx, 0 to a f of a minus x dx. Okay? I will show you the proof how to get it. But I hope number 1 and number 2 you understand. So number 3 can be done easily. Now, giving you the proof here. Proof of number 3. You start with the RHS. Let a minus x equal to z. So minus dx will be dz, dx will be minus dz. So RHS is what? We need to change the limit on it when x equal to 0, lower limit is 0, a minus 0 equal to z, so z equal to a. So lower limit is a, isn't it? Upper limit a is there. How to change it? Again on this only. When x equal to a, 0 equal to z. So this is going to be a to 0. And dx you must change fz. Till this step, I hope you have understood. Just have changed the right hand side in terms of a new variable z. Now this is going to be minus 0 to a fz dz. No, minus sign will be absorbed because you have changed the limit, property 2. And fz dz, first property what we have learned, it is not dependent on the variable chosen. So this we can write 0 to a fx dx, which is equal to left hand side. Am I clear? So 0 to a fx dx, 0 to a f of a minus x dx. I want to show you one direct application of this property first. It's very interesting. A challenging sum in definite integration, how fast can be solved, I am going to show you. Like, suppose I told you to integrate this one, sine to the power 5x dx by sine to the power 5x cos to the power 5x, limit is from 0 to pi by 2. If we do not use property 3, can anybody do this? No one. Even the god of mathematics. Okay? Impossible to solve. This can be done with the third property only. Third property, you try to pay attention once more. If it is from 0 to a fx dx, it will be 0 to a f of a minus x dx. So you start this manner. When you are answering, you let a I equal to answering. Let I equal to 0 to pi by 2 sine to the power 5x dx by okay. Whenever sum is there in this form, where you are able to apply the third property, you take the integrand as I, A, whatever you like, or I equal to, what to do here? X will be replaced by A minus X, isn't it? So this you write sine to the power 5 pi by 2 minus x dx divided by, you understand this transformation?
Yes.
Cos to the power 5 pi by 2 minus x, okay, or I equal to sine to the power 5 pi by 2 minus x is what? This divided by what have you got by using the property? It has become more complicated, or same level of complication is there, because sine is just replaced by cos, isn't it? No advantage. Third property doesn't give us advantageous position for solving the sum, isn't it?
Yes.
But the statement is not true. If we add these two, take this one as number 1, this is number 1 and this is number 2. There will be magic in the next step if we just add these two. Just add these two, adding 1 and 2. What do you get? I plus I 0 to pi by 2 sine to the power 5x so answer is 0 to pi by 2 dx ax 0 to pi by 2, isn't it? So therefore 2I equal to pi by 2, I is equal to pi by 4. Is that clear? Done? So we can apply this property solving sums like this. We'll solve many sums, but let us know the properties first. Third property is done. Fourth one now. It is A to B. A to B fx dx equal to, similar to that, f of a plus b minus x. Here lower limit is not 0. It is from A to B. A to B fx dx should be A to B f of a plus b minus x dx. Here it was a minus x. Here it will be a plus b minus x. And you can take the effort of proving this one also by putting a plus b minus x equal to z. You can prove, but don't do it now. Let us find one application of this sum. Okay? Just one application. Just suppose you are to evaluate pi by 6 to pi by 3 root sin x by root sin x plus root cos x. Okay, see how to answer this. Again you let I equal to pi by 6 to pi by 3, but you need to know both the properties, no? Because using the first one you cannot do this one, second one you need. Similarly, some problems can be done with the help of third property only, we need not use fourth one. Or I will be what? What is A and B over there? It is A plus B minus X. A pi by 6, B pi by 3. So A plus B is 90 degree, isn't it? So A plus B minus X will be what? Or pi by 2. This is pi by 2 minus X. Agree or not? So write this as under root sin pi by 2 minus X am I correct? Done this one. Or I equal to again we need to add this number 1 and this number 2, then you can get answer easily. Just add these two, adding 1 and 2. Adding 1 and 2, I plus I, actually this is 1, no, we have assumed. So your denominator same, numerator it will be added, again we get dx. Pi by 6 to pi by 3 x. Okay, so 2i equal to how much? Pi by 3 minus pi by 6, that is pi by 6. One thing I would like to say, CBSE doesn't ask proving theorems or derivations, but they have asked question this, this derivation of this formula many a times. So you have to do its derivation also. That 0 to a fx dx, so many times they have asked, you must prepare for that. 0 to a fx dx equal to 0 to a f of a minus x dx, or a to b fx dx f of a plus b minus x dx. Okay, same. So now you are master of fourth property also. Done. Let us go for fifth property now. In all 7 properties are there. We will learn one by one. For CBSE, for JEE 7 into 3 at least. They all are based on this. Periodic function will be added, no? When you learn properties of definite integration of periodic functions. Okay, let us know common functions first. 0 to 2a fx dx will be 2 into 0 to a fx dx if f of 2a minus x equal to fx, and 0 if f of 2a minus x equal to minus fx. Okay, let us see one problem here. I am not going to prove this, I am just going to show you one application here.
Can this proof be asked?
This proof, no chance. Can be done with the help of sixth property, I will tell you.
Can the limit be split?
No, that limit, you see, it is from 0 to 2a, we are taking 2 outside. That can be done. For 2 it can be done.
But say we have
Question is for n we can do it or not. Then the function need to be periodic. I will explain in time. Not required for CBSE class 12 mathematics. And even any board exam, WHS, ISC, wherever you go, those properties are not required. These 7 properties only, what given in NCERT book, is in syllabus. Board syllabus, maximum these 7. So let us apply it in one sum. Say they have asked you to find, evaluate 0 to 2 pi sine to the power 17x sine to the power 17x dx only. Say this is the sum. Okay, it's a huge problem. You can take one another term also, I am writing, no problem. Sine to the power 17x, say cos to the power 12x. Such a huge sum without property cannot be done. Wallis formula is there, that we will learn later. But right now, this property will be enough. Which property? That property 5, which we have learned. Okay? See how to. Let, when you are writing descriptive paper in board examination, you need to write everything in details. In details means one line in 10 pages. No, not that. You will explain everything with your own statement, with your own language. So let fx equal to this. You cannot say that I know this is 0, I did it once, so it is 0. No, not like that. Give a proof. Property is there, you need not write this. If you write, it's fine, no one will mind. Okay? Now here, what is a here? A is pi, 2a, 2 pi. So f of 2a minus x we will find. 2 pi minus x sine to the power 17 2 pi minus x. Isn't it? What is sine 2 pi minus x? Fourth quadrant. Sine 360 minus x. It lies in for this quadrant, so minus. And cos 360 minus x, fourth quadrant, plus. It's all right? You understand? What have you got? This was our fx. We found f of 2a minus x. It is coming in the form of minus of fx. So I equal to 0. Enough. You have done it. It may be a 1 mark question, then you write the answer only, you know it. It may be a 2 mark question, then show this calculation, you will be lucky if it is a 3 mark question. Clear? So till 5th property you have learned. Let us go to learn the 6th property. Actually there is no order that 6th property will come this way or 3rd property. No, you can change the order also. It is again on even function. Previous one was not even function. Even function is not like this. What is even function? F of minus x is fx. What is odd function? F of minus x is minus fx. So minus a to a fx dx, this will be 2 into 0 to a fx dx if f of equal to 0 if that is fx is odd, and here fx is even. If it is even, then you take 2 outside, 0 to a fx dx. If it is odd, then it will be 0. Let us evaluate this. One example. One property, one example. Okay? They have asked you to evaluate this thing. Say, evaluate minus 2 to 2 x to the power 11 plus 2x dx. Okay? You need to check whether this is even function or odd function. Then you can write the answer directly. Let fx equal to x to the power 11 plus 2x. So f of minus x is what? What do you observe? This is minus fx. No mobile phone, please. When you study, then you study only. Okay? Practice it with me. Okay. So this is what? This is odd function. The value will be 0. Straight. Clear? Understood? So for odd function, we can write the value directly. Now let us learn next property, which is another very important property, 7th one. Sometimes it comes as third property in my sequence, but I have changed the order. This is actually on the geometrical meaning, which I have told you earlier. A to B fx dx is the area bounded between 2 points A and B. You know it very well, isn't it? If there is a curve bounded between 2 points A and B, then with x-axis the function is y equal to fx plotted a0, b0. A to b fx dx is what? Area. Now suppose you take another point in between, P, whose x coordinate is c, 0. Then this 7th property states that this is A to C fx dx, C to B. A to C fx dx plus is that clear?
Yes, sir.
So let us apply it. What kind of sum is there where you can apply it directly? Okay? Let us start with this one, that is 0 to 2 pi sin x dx. Everyone can do this, isn't it? This is, you know, minus cos x. 0 to 2 pi, it is minus cos 2 pi. You understand? It is minus 1 plus 1, value is 0. Is it possible? Can I make it 0? It is not obeying that property. F of 2a minus x equal to minus fx. No. Minus fx, it is there. Minus fx, it's coming. But if you go by geometrical meaning of definite integration, then you go through the graph. What do you observe there? That concept you will always keep in your mind. This is the graph of sin x, and this is 2 pi. So 0 to 2 pi means this area plus this area. You are getting answer 0, but area is there. How do you explain that part? You will say that 0 to 2 pi sin x dx, we can bring these two outside. Can we check once? Can you take these two outside? Which property is there to take two outside? Please check once.
Property 5. 2 into 0 to pi.
No, that way also you will get the answer 0 if you go by property. But geometrical meaning if you use, then this you have to evaluate writing 0 to pi
Pi to 2 pi.
sin x dx. Again, if you do pi to 2 pi, result will be 0 only. Mod of pi to 2 pi sin x dx. Be careful when you are solving definite integration problem involving trigonometric functions. Okay? So now you can get sin x is what? 0 to pi. This will be this is what? Minus cos 2 pi plus cos pi. So again minus 1 minus 1. Answer is 4. Okay? The value will be 4.
We always check using the graph.
Yes. Now let us take another example here. Say we are integrating this thing, mod x minus 2 dx. Say it is from minus 2 to 3. How to evaluate this? Mod x minus 2 dx.
Minus 2 to 0, 0 to 3.
No. This mod x minus 2, let us redefine. X minus 2 for x less than 2. Clear? So I going to be what? Minus 2 to 2. Function nature going to be changed? No. Isn't it? So this part is what? Minus 2 to 2 mod x minus 2. What is the value here? Less than minus 2, it is negative. And this one is positive. 2 to 3 x minus 2 dx. Alright? So now integrate. Isn't it? So put minus 2 square by 2 plus 4 minus 2 square by 2, and here 4 by 2 minus 4. So this thing getting cancelled. 4 plus 4, 8. 10 minus 3 by 2. 2 LCM. Isn't it? Clear? So see the application of the last property. In this context, I'll tell you the value. What is the value of this integrand? Say integrating 0 to 2 modulo x dx, number 1, and say 0 to 2 only modulo x squared dx. How to evaluate? This property only, where we express one integrand as sum of 2 or more integrands. Okay, try this one, modulo x dx. Modulus function, you all remember, its value changes interval to interval. 0 to 1 it has one value, 1 to 2 it has another value. So this one, number 1, when you are answering, this will be 0 to 1 modulo x dx plus 1 to 2 modulo x dx. You just write the value and simplify it. Just to write the value. 0 to 1 modulo x, what's the value? 0. 1 to 2 it is 1. Isn't it? So just put the value there. 0 to 1, 0 into dx. 1 to 2, 1 into dx. X 1 to 2. This is equal to 1. Clear? Next one is bit difficult. X squared. With the value of x, if you try, it is coming 2 square, that is 4, up to 4. So interval should be splitted accordingly. 0 to 1, x squared dx, then 1 to what? 1 to root 2. Why root 2? Because root 2 square is 2 only, no? Because the function is x squared, that's why. Next one will be what? And the next one, it will be from root 3 to 4. Check any other integer is there in between. Root 3 square maximum, no? Root 4 square, it will be 4 only. That's why. Now we'll be putting the,
limit was from 0 to 2.
we can't, because 0 to 1, one integer is there, no? What is the value of this function? X is lying, you can check the value this way. X,
From 0 to 2, why did we extend to 4?
x greater than equal to 0, less than 1. What does it mean? X square greater than equal to 0, less than 1. So this part will be what? Modulo something which is smaller than 1. So value will be 0. Here x is greater than 1, greater than equal to 1, less than root 2. What about x square? X square greater than equal to 1, less than 2. What is the value there? 1. And the next one, root 2 to root 3. This will be maximum integer, x square is 2, so it will be 2 dx. And here it is root 3 to 4, no, it will be root 3 to 2, sorry.
That is what I was saying.
Yes, root 3 to 2. Who dares not to listen to you? X square dx. So the value is 0 here, and here it is x. Value is 1 to root 2. This one 2x. Isn't it? And next one what to put? Root 3 square, 3 greater than equal to 3 and less than 4, so we'll be putting 3 dx. So plus 3, you can take 3 outside, inside, it doesn't matter. Now go on putting the values. Root 3 to 2. So this will be root 2 minus 1 plus clear? This is just ordinary application of the formula of definite integration you have just got. Okay? Clear? So next session I will be discussing graded problems on it, but before that you need to practice.